U substitution, which a lot of people's like, it's a scary topic, but it's actually quite helpful and very useful in both physics and just as a general calculus principle. So, what is U substitution? Well, fundamentally, U substitution is just a method used to make really ugly integrals much more manageable. So let's just go through a pure mathematics example here. So here I've got an equation. Let's take the integral of 4x times x squared plus 5 to the third dx. All right, so straight math example, just, hey, I want you to integrate this bad boy. Well, integrating this is not pretty, okay? It is not fun at all. So what we're going to do is we're going to take the ugly part and we are going to replace it with our U substitution. So let's just kind of walk through what that looks like. So here's my ugly part. All right, let's get rid of that. And so we're going to replace that just with the letter U. I mean, honestly, you can pick any variable you want, just so many of them are already taken. All right, so we're going to go with just U. So U equals x plus 5, sorry, x squared plus 5. And we always want to say, okay, I want to pick a value of U, because it really could be anything. Usually it's like the ugliest part, and you know it's going to work if both the value you're choosing for U and the derivative is effectively living in the equation already. So du would be 2x dx. All right? So if we look in here, that's already existing, all right? We've got, I mean, it's not 2x exactly, but it's 2 times 2x, so still there's a 2x living in there, and we've got our dx living there. So we can replace this stuff here that I've underlined with our u and our du, and we can make our math much, much simpler. So just to kind of show that out here, we've got the integral of, I'm just going to do some subtle rearranging here. X squared plus 5 to the third. So that right there represents our u. And then we've got that 4x, which is really 2x dx times 2. Well, this 2x dx, there's our du. And then we've got the number 2 kind of left over. So really what we end up having to work with is 2 times the integral of u cubed du. Now, hey, all of a sudden u cubed du, that is, that is so much easier, so much easier. All right, so when we integrate that, we get 2 times u to the fourth over 4. Obviously, if a constant's going to show up, but in all honesty, we rarely care about those in physics. Matter in calculus, but in physics we rarely use them. And so now all we have to do, obviously I can also substitute or reduce this to become a 2. But now I'm just going to do replacement. All right, so I'm just going to take these values again and I'm going to replace them over here. So what I get is u to the fourth, well that's x squared plus 5 to the fourth divided by 2. And then we'd have our plus c, but again, I don't care about that. All math teachers go yell at me, blah, blah, blah. So again, in summary, like this is how you do it. So we made a complex thing really easy. So in summary, the goal of using u and du is to choose a u, like we chose here, that is going to be in the equation. All right, so that was our u over there. And then have du also show up somewhere in the equation in some form. So as you can see, even though we had a 4x, we were able to replace that with 2x, and the dx was already there. All right, and then all we're going to do is we're going to replace those variables with u and du. That should make our math much simpler, as it did here, and then you just bring them back in. That's it. That is the fundamental core of u substitution. So let's just do a physics example now. Okay, so we'll just go through an actual physics example now. All right, so we'll just kind of go there. And let's say we've got some sort of moment of inertia problem. All right, so it's like, hey, the moment of inertia is equal to the integral of position times 1 minus x dx. And again, you're looking at that like, oh my gosh, I can't integrate that. That's going to make me cry. So we are going to just do some substitution. Now again, to just emphasize, when we do this u and this du, u is really just a function in terms of x. So it doesn't have to be one thing, it could be some ugly stuff. It's any function you want. And then this right here is just the derivative of that function. All right, so it's just the derivative of whatever that function is. So it could still itself be something more complicated. All right, so we are going to do u substitution in this example to make our lives a bit easier. Okay, so let's look and try and figure out what do we want to have as our u and what's going to be our du. So as I look at this, I think, you know, what's the ugly part, right? So the ugly part, in my personal opinion, is this entire thing. I'm going to make this entire thing my u. All right, so my u is going to be equal to the square root of 1 minus x. Okay, so that's my, that's not a u. Sorry, that was the coefficient of friction there. Just did that unit in my class, so it's on my mind. So we just got the square root of this equals u, which I can then continue on to say u squared is equal to 1 minus x. All right, because I don't like square roots, I don't want to deal with that. So then I have to say, okay, well, what's the derivative? Okay, so what is du? Well, if I go to that, then I can say, well, du, the derivative of this piece here, is going to be 2u du, because again, du is just the derivative of u. So what's the derivative of u squared? 2 du, or 2u du. All right, and then I got to take the derivative of the other side, so this would just become negative dx. All right, so that's what I've got. That's my arrangement here. So now I can go in and I can now do my replacement. Okay, so if I do some straight manipulation, I'm just going to make this over here a plus, making that a minus. And then if I look over here, I want that to be an x. No, I'm going to leave that as it. Oh, don't jump ahead, Smansky. Don't jump ahead. You got this. All right, so I'm going to kind of leave that as it is. No, I'm not. That's a lie. So let's do this. So then x, just a little more algebra here. So x, let's subtract that, is equal to 1 minus u squared. So now what I have is I've got x equals and my dx equals. So now I can go in and do some fun super substitution as I see fit. All right, so now let's revisit this. So I've rearranged it so I now know x equals 1 minus u squared. So I'm going to integrate, well, x is 1 minus u squared, so 1 minus u squared, times, as I already showed, that's now u, and then dx, well, dx is equal to negative 2u du. So now what I can do is I can kind of algebraically manipulate this bad boy so that I can eventually do some math with it. So I'll pull out my constants, negative 2. Let's just do some manipulation. U squared minus 1 minus u du, negative 2. So I'm just like arranging things around here. You can probably see where I'm going with this. U squared minus u to the 4th. Whoops, made a mistake here. I'm human, that's squared. I hate when sometimes you're writing stuff and you just like drop something or you put it in the wrong place. You're like, oh man, I knew it. I was just going too fast. There we go. Because I was like, wait, that does not match my notes. So sorry about that. So we've got u squared minus 4 du, and now this is way easier because we now know that this is equal to negative 2 times u to the 3rd 3 minus u to the 5th over 5. All right, so we're good there. And so now what we got to do is just kind of distribute our negative 2 back in, which is going to allow us to do a little bit of rearranging here. So we end up with 2/5 u to the 5th minus 2/3 u to the 3rd. It's like, all right, cool, I'm done. Well, no, you're not. Remember, you got to do that substitution back in. So let's do that. All right, so let's grab our u values, and we basically said that u is equal to the square root of 1 over x, or as I like to, honestly, I leave it as u is equal to 1 minus x to the 1/2. I don't like the square symbol. I like to leave it as powers. So when we do that, we then get 2/5 times the quantity 1 minus x to the 5/2 minus 2/3 times the quantity 1 minus x to the 3/2. So I ain't saying that's pretty at the end. It's not. But this is way more palatable than if we were not to use the u substitution. So again, in summary, you use that u substitution, we've got something ugly, but you can also arrange it so that something ugly also has its derivative living inside of it as well. That's how you got to choose that u value. All right, so that's basically what we did here. All right, so we said this is the ugly part, so I'm going to make that my u. I rearranged it so it made a little more sense in terms of, say, x. I then got the derivative of that and got dx, and then I was able to even, like a second time here, say, hey, by the way, I can rearrange to say x equals some stuff, and kind of work through the problem. And then at the end, once you get to here, you're just going to do your substitution back in to get yourself an answer. Okay? Hopefully that helped, and as always, I'll see you guys in class.